Hi everyone, I hope y'all are all doing okay and staying home and staying safe and completing your assignments on time. Today we're going to review solving exponential equations for your upcoming quiz. So let's get started. All right, let's take a look at our first example. We have 5 to the 2x minus 1 equals 5 to the third. Both sides of my equation are as simplified as they can be, and both my bases are the same. That means all I have to do is drop my bases and set my exponents equal to each other. So that gives me 2x minus 1 equals 3. Okay, now I want to solve for x. So my first step would be to add 1 to both sides. It'll cancel out here, leaving me with a 2x equals 3 plus 1 is 4. Now I need to divide both sides by 2. It'll cancel out on this side, leaving me with x equals 4 divided by 2 is just 2. Final answer. In this example, I can see that I need to simplify this side of the equation. Okay, our properties of exponents tell us if I have two numbers of the same base being multiplied together, I just need to add the exponents. So I'm going to rewrite this as one term. It's going to be 2 to the x plus 2x minus 3. So all I did was add those exponents together, and this side will stay the same. So I can still further simplify this. I have an x plus a 2x, so my power can be rewritten as 2 to the 3x minus 3, okay, equals 2 to the 3x. Now I have the same base. Each side of my equation is as simplified as it can be, so I'm just going to drop my bases and set my exponents equal to each other. That gives me 3x minus 3 equals 3x. Now I need to solve for x. To do that, I'm going to move all my x's on one side and all my constants on the other side. So let me move this 3x. I'm just going to say subtract 3x from both sides. It's going to cancel out here. I get negative 3 equals 3x minus 3x also cancels out to 0. So I have negative 3 equals 0, which is a false statement. Therefore, there is no solution. In this example, we actually don't have the same base, so I do need to manipulate these to get them to equal each other. It kind of helps to look at the bases that you are given and think to yourself, is there anything obvious that I can do to one or both of the bases to get them to be the same? Well, I've got a 6 here, and I know that 6 squared is 36, okay? So I'm going to rewrite this one as 6 squared to the x power equals 6 to the 2x. All right, and over here, our properties of exponents tell us if I have a power to a power, I just multiply those. So this will be rewritten as 6 to the 2x, and this side will stay the same. So now I have the same base on each side, so I can just drop those and set my exponents equal to each other. 2x equals 2x. And you really don't have to solve at this point because this is a true statement. You know, if you were to solve it, you would say, well, let me subtract 2x from both sides. This leaves me with 0 equals 0, which is obviously a true statement. So I can say it's all real numbers as my solution. In this example, the first thing you might notice is that none of your bases are the same. You have a base of 3, 9, and 1 over 3. So we want to change all of those to have the same base. And just looking at what you do have, it would make the most sense to change them all to a base of 3. All right, so this one would stay the same, 3 to the 2x, times 9 is the same thing as 3 squared. So I'm going to rewrite that as 3 squared to the 4 minus 2x power equals 1 over 3 is the same thing as 3 to the negative 1 power, and it's to the x power. All right, so now I'm going to go through and simplify the bases that I've manipulated. So I've got a power to a power. That means I need to multiply these, all right? This one will stay the same. So I've got a 3 to the 2 times 4 is 8. 2 times negative 2x is a negative 4x. On this side, I've got a 3 to the negative 1 times x is a negative x. All right. Now, this side of the equation needs to be simplified. So let's go ahead. We know that we have the same base and we're multiplying, so we need to add these exponents. I'm going to rewrite it as one term, 3 to the 2x plus 8 minus 4x. So I've got a 2x minus 4x, that becomes minus 2x. Don't forget your plus 8. Okay, perfect. Now we've got a fully simplified equation. We have the same base. So now all we have to do is drop the base and set our exponents equal to each other, leaving you with negative 2x plus 8 equals negative x. To solve for x, I'm going to move all my x's on one side, all my constants on the other side. So if I add 2x to both sides, it'll cancel out here, leaving me with 8 equals negative x plus 2x is a positive 1x. All right, so I get 8 equals x, and that would be my final answer. All right, in this example, we've got a fully simplified equation. However, our bases are not the same. So I have to think of what I can do to get these to be the same. And it's a little bit tricky until you remember that anything to the power of 0 is equal to 1. So I can rewrite this as 2 to the 4x plus 2, so this would stay the same, equals 2 to the 0 power, because these are the same thing. It means the same thing. And now I have the same base. So I can just drop those bases and set my exponents equal to each other. Now I would want to solve for my x. First thing I do is subtract 2 to both sides, leaving me with a 4x equals negative 2. Divide both sides by 4. You get x equals negative 2 divided by 4 is a negative 1/2. Final answer.